I'm going to set up a voltage monitoring board to monitor my 12 volt batteries. I just want to keep an eye on them when they're fully charged and when they discharge too low. And I want to be able to check that over the Wi-Fi, home Wi-Fi system. A really good board for that is this ESP8266 board. They're really cheap, you get them for under $7 Australian each. They've got heaps of capabilities and functionality. You can see by the pin-out diagram. And you can also get these boards here, which are like a development board, so you simply plug them in. It gives you easy access via all the simple screw-in pins as well. Now these boards run on 3.3 volts. They have a USB input, which is obviously a 5 volt input, but converts those through a regulator to 3.3. What that also means is that the analog input pin for this only can handle 0 to 3.3 volts. So I can't just simply plug in 12 volts because that'll kill the board. So I need to drop that voltage down, the input voltage down, into a range that this thing can handle. The easiest way and cheapest way to do that is just to use a voltage divide using resistors. I'll just explain how that works. So the diagram in front of you shows the divide network of the resistors between the battery and the ESP board. A couple of things to take into consideration when you're working out this divide network ratio and values is, firstly, what's the highest voltage you're going to be inputting. You just need to make sure the ratio keeps that highest voltage below 3.3 volts once it's converted down. The other thing is to use high value resistors that are well into the kilohertz range. That minimises the amount of current drain you're just losing straight through the resistors from the batteries, positive and negative. So if you get them high up in the range, like I'm showing here, about 35k and 10k, that should keep you out of trouble. Now the way you calculate the voltage divide is the input voltage that you want to set, which in this case is 15 volts to be the highest voltage, and then it's the sum of the two resistors divided into that voltage and then multiplied by the resistance of the resistor between analog input and ground. So in this case, with the example, it's 15 volts divided by 45k times by 10k gives me 3.33 volts. So when the voltage gets to 15 volts on the battery, the input voltage will be 3.33 volts into that analog input. From there down, it's not really an issue. You can work your way down to 0 pretty much from there. So if you want to work out your voltage divide ratio, I've put a link in the description. You can put in the voltage input you want to be dealing with as a maximum. You can put in a resistor value. You can put in output voltage, and then you can determine what the other value resistor you need is. For me, with the maximum of 15 volts, I picked a 10k ohm resistor, a very common resistor, and the other ratio that I need to try and keep the voltage readable at about 15 volts is 35 kilo ohms. There's not a 35 kilo ohm resistor, but I found by using two 68k ohm resistors in parallel, and because the imperfections in resistors being up to 5 or 10% depending on what you get, putting these two together gave me basically 35 kilo ohms. So using a 10k ohm resistor and pair paralleled of 68k ohm, I've got my 35k ohm. So to put it together, I'll use the development board, so we'll just get that sorted. The pins pretty much match up one for one. So the good thing about this is there's earth pins on both sides, so there's an earth pin here and an earth pin here. I'll show you why that's a benefit in a minute, but let's get this these pins sorted. So I'll run the 10k ohm from earth down here to the analog input, and I'll run the 35k ohm off that point and then off to the input from the battery. And the negative side of the battery will just go to ground over here. So let's put that together. Now I'll put the earth, they'll use this earth since this one's already taken, this earth on this side which was shorter to the one I just used. That'll go to the battery negative. And that's it. That's how you need to divide network. So this will go to the positive of the battery, this to the negative. Set up for an 18 volt range. So now we'll move on to programming the 8266. You need a couple of things to do that. You'll need to set up or install the Arduino IDE. I've provided a link in the description that'll get you there to download and how to install it. Once you've installed that, you'll need to get the ESP8266 drivers and install that into the IDE so that it can connect and work with the board you've got. I've also got a link in the description to where you could go to get that. It explains how to install it as well. Now this program is pretty simple. It sets up a web server itself, and you basically access that web server and pull whatever information off it you want. In this case, it'll be a value that indicates what voltage it's measuring. It's a raw value, so it's just a binary value from the range of the analog input pin, and the next code I show you, which is a Python code, converts that to a voltage. But in this case, all you need to do is get a your Wi-Fi's name, put it into here, your Wi-Fi password into here so it can connect and work through your Wi-Fi, and then allocate this particular device an IP address, obviously one that you've got spare in your home network. Then after setting those things, the rest is all just mostly protection, apart from reading the analog pin, a few simple things that happen. So that's about it. So we'll just program now. So make sure you've, from the instructions you've seen, you set the right board that you're working with and what port it's connected to. From there, it's just a matter of uploading, which is sort of a compile and verify, and then it'll program the board. And done. So once that's done, you'll be able to actually open up a browser, put in this IP address, and it'll connect. You won't see anything come up because there's nothing to be displayed, but it'll give you a blank screen on your browser which shows it's working. If you've got no connection, you'll come up with a connection error. Okay, now let's look at the Python code that goes with this. So this is the Python code, very simple bit of code for what it does. There's a simple sleep time added in just so that it checks the voltage every 60 seconds. The request is used to access the web server. It's a built-in library for Python. Here you put in the address that you allocated to your 8266, and that's it. The one thing you'll need to set though is the converter. So this is the value that I use to convert the value that comes from the 8266 into a voltage. That's going to vary depending on your divide network and what voltage range you're trying to work with. You can calculate that out by using a multimeter, measure the voltage that's on your battery and have a look at what's being displayed, and you can vary your converted value to make the two align. It's a linear change that comes out of the 8266, so whatever you set here will be, and get that right, it'll be consistent with all the voltages. When you run the code, it opens up a window and displays the voltage. Then every seconds it'll check. At the moment I've got nothing hooked up to the device, so it's just reading an open circuit basically there. That's it.